Hello boys and girls. In this lesson, we are going to learn about exponents. In our day-to-day life, we often use acronym or short forms for a big word like OMG for oh my god, DOB for date of birth, KA for Khan Academy, ASAP for as soon as possible. Have you ever thought why do we use these acronyms? It's because they give us a shorter way to remember words for large names, and it's much easier to write and read as well. Is there a way we can do something similar with numbers? Astronomers, biologists, engineers, and many others encounter quantities whose measures involve very small or very large numbers. For example, the distance of the Earth from the Sun is approximately 144 billion meters. The speed of the light is 300 million meters per second. The average diameter of a red blood cell is 0.000007 meter. It is sometimes difficult to read, write, compare or work with such numbers. This difficulty is overcome by using the concept of exponents. Alright then, but what are exponents? Well, it's just like the four main arithmetic operations that we use in math. Exponents are a type of math operation. Exponents tells us to take a number and multiply it by itself a certain number of times. In other words, exponents are basically repeated multiplication. To help you understand what I mean, let's review multiplication first. You know that multiplication is basically repeated addition. For instance, 3 times 4 is shorthand way of writing 4 add 4 add 4. It's the same as 3 4s added together to give us a sum of 12. Now let's compare that to a similar exponent. Yup, that's an exponent and we will understand it in detail. But for now, you just need to know that this exponent tells us to take a number 3 and multiply with itself 4 times. In other words, we take 4 3's and multiply them together. That is 3 times 3 times 3 times 3, which is equals to 81. So multiplication shows repeated addition and exponent shows repeated multiplication. That's pretty simple, right? Now let's understand the basic terminologies used in exponents. Exponents basically involves two numbers, base raised to exponent. For instance, 2 raised to 4. Here 2 is base or root, which is the number that gets multiplied repeatedly a certain number of times, and 4 over here in the superscript is called as the exponent or the index, or very often is called as power, which represents how many times the base being multiplied together. And this is read as 2 to the power of 4 or 4th power of 2 or simply 2 raised to 4. So 2 raised to 4 is called as exponent form, while 2 times 2 times 2 times 2 is called as expanded form, and which is equals to 16 is called as the standard form. Let us review basic exponents question before moving ahead. First, 5 to the second power, which is also called as 5 squared, which means that we are multiplying 5 2 times with itself. So 5 times 5 equals to 25. 6 to the third power, which means 6 cubed. So 6 times 6 times 6. So 6 times 6 equals to 36. 36 times 6, which is equals to 216. 10 to the fourth power, which means that we are multiplying 10 repeatedly 4 times with itself, and this is equals to 10,000. Negative 3 cubed, which means negative 3 times negative 3 times negative 3. So negative 3 times negative 3 is 9. 9 times negative 3, which is equals to negative 27. Negative 2 to the fifth power. So negative 2 times negative 2 times negative 2 times negative 2 times negative 2, which is equals to negative 32. Negative 7 to the second power, which is equals to negative 7 times negative 7, and which is equals to 49. Fourth power to the negative 4, which means we are multiplying negative 4 4 times with itself. So negative 4 times negative 4 is 16. 16 times negative 4 is equals to negative 64, and negative 64 times negative 4 equals to 256. Here, please keep the following things in your mind. Whenever a negative number is raised to an odd power, we are getting answer as negative. And whenever a negative number is raised to an even power, we are getting answer as positive. So we can say that negative number raised to the even power, we will get answer as positive. And negative number raised to an odd power, we will get answer as negative. Now I hope that you would have understood the basics of exponents. So let's begin with the laws of exponent. First law, law of multiplication, which is also called as the product rule. For example, what if we want to multiply 3 to the second power by 3 to the third power? Both of this have the same base, which is 3. So with this in mind, let's go ahead and simplify it. Let's start off by rewriting each term in an expanded form, as in 3 to the second power as 3 times 3, which is further multiplied with 3 to the third power, which means 3 times 3 times 3. Now notice here that we have 3 being multiplied with itself 5 times. Another way of saying this is 3 to the fifth power, or 3 to the power of 5. You may have noticed that 5 is equal to the sum of 2 and 3, and this turns out to be one of the laws of exponents, which is called as a product rule, which states that during multiplication, when the bases are same, then the exponents are to be added. So in short, we can say that since the bases are same over here, which is 3 in this case, we can directly add the exponents to get the simplified form of this. So 3 raised to the power of 2 add 3, which is equals to 3 to the power of 5. So in general, we can say that when a is raised to the power of m times a raised to the power of n, since the exponents having the same base are in multiplication, we can add the exponents. So finally we can conclude that when multiplying two or more exponents that have the same base, you can add the exponents. Let us solve few more examples by directly applying the product rule. First, 3 to the 4th times 3 to the 8th. Here, since the exponents having the same base are in multiplication, we can directly add the exponents. So the simplified form of this will be 3 to the 12th. Negative 4 to the 5th times negative 4 raised to 1. Here, when there is no power, it is considered as 1 by default. So here, since the bases are same, we can apply the product rule. So here it will be negative 4 raised to 6th. X to the 4th times x to the 5th times x to the 6th. Here, since the bases are same and they are in multiplication, we can directly add the exponents. So, which is same as x to the 15th. Here, since the bases are same and they are in multiplication, we can directly add the exponents. So, this is same as 7 upon 4 raised to 9. Now, let us understand the second law of exponents, which is raising a power to a power, or the power rule. To see this rule, let's start off by taking a look at an example. Well, let's say that we have 7 cube and we raised it to the second power. Now let's simplify this. Since the 7 cube is raised to the second power, it means that we are multiplying 7 cube with itself 2 times. So it's 7 cube times 7 cube. Now here, since the exponents having the same base and they are in multiplication, we can apply the product rule by directly adding the exponents. So which is same as 7 to the 6th. And take a look at this. 6 is the same thing as 3 times 2. So in this example, we could have simply taken 3 times 2 and gotten 7 to the 6th. And we could have skipped these steps. Great, isn't it? In fact, this trick works in general, and that is the power of a power rule. So the general form of power to a power rule is that for any number a is raised to the mth power and then raised to the nth power is the same thing as a and raising it to the power of m times n. So we can conclude that when raising a power to a power, multiply the exponents.